Coulomb's law. Now we can discuss some important facts about the Coulomb's law on which the problems or numericals are solved. The first fact is stationary charge particles. Coulomb's law is valid only for the stationary charge particles. The moving charge particles does not obey Coulomb's law. The second fact is the Coulomb's force, Coulombian force or electrostatic force is purely conservative force in nature. That is, the work done does not depend upon the path followed by the particles. Depends on medium. This type of force depends on the medium. If the medium changes, then the force also changes. Follow inverse square law, that is F is inversely proportional to R square or Fr square is equal to constant. If the distance between two charge particles changes, then the amount of force acted between them also changes. Obey Newton's third law. That is, if charge particles apply force F1 on the other and F2 applied on the first, then these forces are equal in amount and opposite in the direction. And if we write in the terms of only magnitude, then the magnitude of these forces are also equal. Follow the vector algebra. These forces are also follow the vector algebra. That is, if two forces F1 and F2 are at an angle theta, then the resultant force between them is given as F under root F1 square F2 square plus 2 F1 F2 cos theta. And the direction of resultant force with the F1 is given as tan alpha is equal to F2 sin theta upon F1 plus F2 cos theta. Follow the superposition principle. According to the superposition principle, the total amount of force acted on any charge particles is equal to the vector sum of all the forces acted on the charge particles. Then F is equal to F1 plus F2 plus F3, etc. In vector form, we can write the force F is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R cube, and this is the vector R which defines the direction of force. Here we discuss the important property, that is the electrostatic force or Coulombian force is totally depends on the medium between two charged particles. If the medium changes, then the force also changes. Then the different value of the dielectric constant for the different mediums are listed here. Medium and the value of K. Vacuum. For the vacuum, the value of K is 1, while air, the value of K is 1.0003. And for paraffin wax, the value of K is 2.1. For rubber, the value of K is 3, while glass, the value of K belongs from 5 to 10, because the glass are of many types: Crookes glass, flint glass, etc. Silicon 12, germanium 16, glycerin 50, water 80, and last metal, that is infinity. That is the value of K for the different mediums. There are many questions arises according to the medium. The first is that if the medium between any two charged particles are filled with the metal, then what happens? If the value of K for the metal is infinity, if we place in the Coulomb's law the value of K 1 upon 4 pi epsilon 0 K for any medium, Q1 Q2 upon R square. Here if we place the value of K for metal for there is infinity, then the force acted between any two charged particles, if the medium between the charged particles are filled with the metal, will be 0. If the medium here Q1 and Q2 between the space is filled with the some types of material having thickness T, then the effective distance between the charged particles will reduce to R dash, that is R minus T plus T root K. That's all about the important fact, Coulomb's